to do this question. Hypothetical A equals to 32 minus B minus C, and then B equals to 32 minus A minus C.
Oh, no, there's no point.
No, not B. I only did A, and then you would only get up to B and C values. And then
Yeah.
after that, but that's like, when you do it, I don't know, but I feel like when I do that, I've reached like no solution or something like that. And then using that, you use B equals to whatever, and then like substitute until you find like one of the values. And then you have to repeat that process again to find the other two values. I feel like it's a really complex method though. And I didn't end up getting a solution, so.
Okay, so the A plus B, the A, B, C are positive integers, and A is the biggest one, right? You want to find the value of A, B, C. Oh, sorry, A is bigger than C, so maybe B is the biggest. But A is definitely not the smallest.
Yep.
And so they add up to 32, which automatically means they can't be that big, right?
Yeah. Maybe, and then after that, I tried like combinations because I thought if they add up to 32, then there's not like that many values for them. So I can just guess and check all of it. Went through like a whole list. I didn't end up finding a value.
Okay, they're all positive integers.
I did another oh wait. I didn't realize what you think. But I found like, so I moved, well I didn't move, I like minus, looking at the first equation, I minus A, I added A on both sides. So then on the left you got A plus B plus C plus AC. I did AC plus 32 equals to BC plus 2A plus 66.
Okay, yeah, that doesn't sound like a bad idea. That's the same as subtracting the second equation from the first, yeah? So...
Oh yeah, it is. But
so you get A, C minus A. I like this first step, yeah? Because B, C plus A plus 34. Wait, so when you read the solution, did you understand the solution, or I'm talking to Ethan? Is it already spoiled for you somewhere? I don't like the word "the solution." There could be many solutions. A is bigger than C. A times C is already bigger than 66. Yeah. Yeah, I don't know, maybe you could try to find another way, because like if this was your first step, right?
Wait.
So if this is your first step, then completing the solution from here
it's really hard. That's what
is a way to justify how to get partial marks. So I mean, a lot of the time people are just kind of lazy, so they'll probably just give you 0. But if you were like IMO or something, we'd like take this as the first step and see if we can finish the problem from here. And if it uses this first step then we could kind of figure out how many marks to give that. Alright, keep thinking about it. Just think of the bathroom for a sec.
Oh,
Okay, and then I liked your idea of substituting as well because I guess you have the basic principle behind solving equations is you use one equation to get rid of one unknown, right?
yeah, but in my case, it's like,
But why did you choose to get rid of A?
hmm,
I guess that's so when you do that, you have three choices, right?
I think appears twice, C appears, I would get rid of C.
Um,
It appears 3 times, B and A appear twice.
so
I did A because it was the first one.
yeah, I don't know. I mean, so the condition doesn't have anything to do with B, right? So I might be tempted to get rid of B, and then I have a condition that says A is bigger than C.
I see. But I don't know. And I feel like using A plus B plus C, you could get what A times B plus C is. Just that equation. Okay. Then you get that A equals to 32 times. And I guess if you use A equals to 32 minus B minus C, and you times it by B times it by C, and then you distribute it again, you will, and then that's A times B times C.
Mm,
But we have to find like two of the values from the derivative. I don't know. I'm not sure.
yeah, I mean, I guess the question is like, is it possible to solve the equation for A, B, and C, or do you can only find out the product? I mean, from experience, it's like the product is just a way to get a three-digit answer, yeah? So it could even be possible you can actually even figure out what A, B, and C are. Which is a little bit interesting because you only have two equations, right? But the thing is, these are what's called Diophantine equations. They have integer solutions. I really don't remember solving this question, but I'm sure I did, or maybe I did. I can't remember. It was like last year. But
Wait, where do you find the solutions?
um,
You just Google AIMO.
so I'm assuming Ethan got it from the AMT website or something.
There's no 2021 AIMO on the AMT website. They only offer 2017, 2018.
Oh, really? I never look at the solutions, so I don't really know.
I only see the question papers of the 2017 and 2018.
Actually, there's the 2021 Australian scene, which is on I think also on AMT, and I think that should have the solutions.
Australian what?
Australian scene. It's like a summary of all of the
What? How do you spell it?
like SCEENE. Is that where Ethan got it from? Yeah. Okay, good.
I thought it was like you know how it's like AIMO and like AMC. I thought it was like some other acronym that was just
Yeah, so I don't know. So I think it's different solving a problem when you got other people with their first step. So would you like to do your first step and we can try and so was your first step to substitute or
my first. Okay, so I tried this like in like 3 methods. I don't think it works.
I don't know what you mean by they don't work, but yeah, keep going. So what were your methods?
So my first method was to use A equals to 32 minus B minus C. Substitute that into the first equation and work from there.
Okay.
Then you would get what B, like you would get, and then using that you could substitute the B and C values back into the second
Yeah,
equation.
that doesn't make sense. Okay.
Right, so you substitute B and A.
Once you substitute, that equation does not exist anymore, okay? Like you can't
But then
use that equation like the way you just did, you know?
yeah, exactly. So then you don't have another equation to use.
Yeah,
So,
like you can't do something and then undo it right away. Yeah, that's basically
like if you get A plus B plus C equals to 32, I'm saying that, and then you substitute it into the next equation, then
yeah.
you'll get the equation for B and C. But then
Yeah.
why do you substitute next one?
But you wouldn't substitute. There's no more equations.
Exactly. So that method didn't work.
No, that you didn't know how to finish it from there. The method is fine.
Oh
You
really?
understand? Yeah, of course. I mean,
Okay.
it's equivalent to doing that ultimately. I mean,
And then from B and C, I tried to put that back into A plus B plus C equals 32. Because I got what? So I got that 32 minus B minus C plus whatever plus let's say using the first equation we got that B equals to something. I forgot what I got, but
no, there's
and then
no.
you get 32 minus that or C minus C plus that that whatever B value was plus C to 32.
Okay, I mean that doesn't make sense because you wouldn't get rid of a variable that way, right?
Mhm.
So okay, so the step of substituting like A equals 32 minus B minus C, yeah?
Yeah.
That's fine, okay?
And then we substitute that into the first equation.
Yeah.
So you get 32 minus B minus C times by C plus B plus C equals to
Yeah.
BC plus 32 minus B minus C plus 66.
Okay, but yeah, so but obviously you have to so as a mathematician you have to be aware of your choices, okay? So you actually had three choices there, A, B, or C, right?
Mm-hmm.
I might have just if I didn't know any better, I might have been tempted to use B, okay? So I mean we could try A and see how it goes. But
Right, so what I meant is, and then after like we simplified the first equation, I thought I was going to write B
yeah, I know, yeah.
subject to C.
And I'm replying to what you said before, right?
Okay.
So I'm saying there's no point doing that. You can't substitute it back to the second. Like you can get so, but there is a point to write B as the solve for B in terms of C. Yeah, right. But there's
Then
there's
what
no
would you
point
do?
substituting
Then
into
what
another.
would you do from there?
It depends what you got, right?
Okay.
So you got A equals. So you got C minus 1 times 32 minus B minus C. Yeah. So I'm already worried about the choice because I would have chosen B and then but
Then just use B.
but then you wouldn't see what you would have done. So if you had C minus 1
Wait, why is
plus
it C minus 1?
put the A over here.
Oh, okay.
Plus C equals BC plus 66. So this is what you had, right? Uh,
And then it would develop into something like a two variable quadratic.
Two variable.
because you would have c squared.
Okay, so let's have a look. You have a minus BC, a minus C squared. Okay, so let's try to expand this. So you have 32 C minus 32 C minus 32 plus 2B plus C. It's 2B plus C plus or minus C B plus C equals BC plus 66. Yeah.
Wait, why is it 2b plus c?
Oh, I mean, just expand this. Minus 1
Minus like
gives
maybe.
you plus B plus C, right? And you already have a B plus C.
Oh, okay, okay. And then you would get, because there's another b plus c, you get 2 plus c bracket b.
Yeah,
Oh,
exactly.
sorry, 2 minus c.
Yeah. Hmm. So you want to treat this as a quadratic in C, is that what you're saying?
I mean, c becomes squared. And I
Yeah.
don't know how to continue on if c is squared without doing
Okay,
that.
well let's just see what naturally happens, okay?
Okay.
Okay, so if you have a minus CB, that's you can have 2BC here, right? And 32 goes to 90, 98. Yeah.
Mm-hmm.
And then you put the C squared here. And then maybe we'll put everything to the side then. Then minus 2B minus 2C minus 32C. Oh, so that's minus 34C, yeah?
Mm-hmm.
This is not good to do this, but
So then we have c squared, and then we have loss c bracket 2b minus 34, and then add
yeah, let me
bracket
just put it
98.
on this. For some reason the zoom thing is not easy to write. The whiteboard is easier for me. Okay, so we're trying to solve this equation, right?
Plus 28 minus 2b.
Okay, so do you guys know how to solve quadratic equations? So you get C,
So I've worked out that c squared plus c bracket 2b minus 34 plus 98.
yep,
And we either, for quadratic, we either use the formula or make a perfect square, or
yeah, you can try factorizing it.
I don't
But I think the formula might be,
best.
I don't know, it might be a bit more instructive right now because in your preparations, I guess it's like seeing lots of magic things is not necessarily great.
2b minus
34 minus 2b
negative
also
2b
minus,
plus 34 plus 1 root. So that's 4b squared minus, God, 78b plus, what's 34 squared?
Oh, what an interesting expression we have there, yeah.
4 times 1.
Let's divide this by
100, 400 minus 8, 2 plus 8b. Wait, would that be a quadratic inside a quadratic? Because in the root, it becomes a quadratic. B squared.
Yeah, I mean, it's not really it's not that it's a quadratic.
Like,
It's more that so if you look at this, c equals, so c is an integer, right? 17 minus b is an integer, okay? So this root thing has to be an integer as well, you know?
yes.
So it's not easy for this root thing to be an integer, okay? So that's why I would think this is actually substantial progress in the problem because I think this limits the values of b to like maybe only a couple.
Isn't b minus 7? Wait, I got b is equal to, wait, I got the b value like in the quadratic equal to b minus 30. It's b minus 17, not 17 minus b.
Wait, isn't it minus b?
No, I'm talking about inside the root.
Oh, it doesn't matter, you're squaring it, so like if you square it, it doesn't matter if it's negative or.
Yeah. That's true. But when you expand it, it's different.
No, it's definitely not different.
Oh no, it's not different. Right, sorry. I was thinking about 17 minus b and 17 plus b.
Yeah.
Yes. So it's b squared minus 34b plus 289 minus 196 plus 2b.
Oh, so you expanded the square root?
Yeah.
Okay, so this is 289.
So I got b squared minus 34b plus 289, and then minus.
Minus
Wait,
98.
you know how it was 498 minus 2b?
Yeah.
How come it becomes 98 plus 2b?
It's the minus sign.
Oh, but wouldn't it be true? Bracket? Wait, am I?
No, the 4 is in the
divide by
square root.
2 inside. Yeah, okay. But, okay, yeah. Wait, but in the square of a square root, you divide by 2.
Yeah.
Okay, I need to.
Yeah. So basically, yeah, like, so this is not me solving the problem, right? This is me showing you how your solution could be extended further. Does that make sense?
Yeah.
So
98 plus b. And so we would get 11 plus minus root. So 289 minus 98. Root 191 minus 35b plus b squared. What's another? Wait, what's the 191 divisible? not by 3. Is it because by 7? No. Um. um,
I guess
This is like 30.
this is b minus 16 all squared. So 16 squared is 256, yeah? 256 minus
Oh, is that
65.
wait? Okay. B squared minus 32. It's not 35b. Wait, 1 second. Oh yeah.
Right, is Ethan and Aiden still following? I mean, calculations might be a little bit hard to follow, but if you do it on your own, it should be pretty simple.
Oh, I'm still here.
Okay, so it's quite restrictive because b minus 16 squared minus 65 has to be a square number, right?
Mm-hmm.
So a square number minus 65 has to be a square number.
Mm-hmm. So, oh, wait, so basically, you know how like each square number they differ by odd numbers. So like 1 to 4 is 3, 1 to 4 to 9 is 5, and then
Mm.
9 to 16 is 7.
Mm-hmm.
Because these two square numbers differ by 65, then we could work out which two square numbers they are. I can figure it out. So if 1 to 2 is in minus is 3, then 2 to 3 is
Maybe it's like 5 or 13.
times 2 plus 1. So 65 equals to 2n plus 1. So even minus 64 equals to 2. It'll be 32.
Okay,
So the
so
square
b
numbers
is
are
7.
32 and 33. And so B is 6.
Smallest square number is 81. 81 minus 16 is 16. Ah, okay, so if b was 7, it would work.
Wait, so if the
What are is b
wait,
equals 7 the only thing that works?
B equals to 7.
No.
B equals to what? Sorry?
Ethan said b equals 7.
But would that be negative? 7 minus 16 squared.
Yeah, I mean squared, it's positive, yeah. Squares are
Right.
positive.
Sorry.
So you get 9 squared, yeah. Okay, so that's very good. So b equals 7. See, yeah. Yeah, so I guess a good chess player, they set up the moves so that you don't
Oh,
have
so we
trouble
get
later
that
on. But
B equals to 7.
well, I mean, there could be other possibilities. Are there other possibilities?
Wait, if let me check this one quickly. B equals 9.
So 81 is definitely the smallest possible one above 65,
256. But
and then it's like 100, right? Which doesn't work.
65.
121
9, 191.
doesn't work.
Wait, is 191 a square number? It's not right.
Hmm?
Wait, is 190? No, it's not.
191 is not a square number. Okay, so trial and error. So how many squares did you try above? So I guess I tried 121. Did you try 144? Yes. 79, that doesn't work. You try 169, then you get 104, doesn't work. You try to the square, 196 is the next one. Minus 65 is 131, it's not a square.
And then it's 225. Minus 65 is 160.
Yeah, it's not a square. And then you're really kind of running out of options here.
256 minus 65.
That's
Is
191, right?
Yeah, and then
Not a square. So that's all the values of b lower than 7, right? Yeah. Yeah. And then if it's bigger, up to 16, it'll get less than 81, right? And then if you go b is 17, it won't make a difference until b got to. It won't make a difference until b got to 25, right? So b could be. Sorry, b could be 25, yeah. So that's another way to get 81, right?
What's 81?
Huh? There's a b minus 16 squared. So b was 25, you get the same, you get 9, right?
Yeah.
So, okay, and then probably for similar reasons, it's going to be harder to find another value of b, right? Because b can't go over 32, remember?
Yeah.
So, like, if you go up by 1, remember, we got up to all the way up to 15, so that would go all the way up to 31, right? We got up to 16, yeah, 32. So there's only those two values of b, yeah?
Yeah.
So that's a...
We work out one possible value.
Yeah. And both cases actually give you, so this square number is 16 then, yeah? In both cases.
Yeah.
So then C equals 17 minus B plus or minus 4, right?
Yes.
C equals 13 minus B or 21 minus B, yeah? Okay, and each of these, 13 minus 25 doesn't make sense, right? 13 minus 7 is 6.
Oh, so B has to equal to 7.
Yeah, I guess, yeah.
So C is equal either 6 or 14.
6 or 14. I'm sure one of these doesn't make sense, right? So which of these, what's A plus B plus...
Oh, A has to be greater than C. So then we can find out the remaining value of A. So let's say that 32 minus 7 equals to 25, right? If B is 14, then A must be 11. So C must equal to 6 and A must equal to...
So B equals 7, right? So A plus C equals 25.
5, and then A must be greater than C, so C must equal to 6. And A is 19.
Ah, yes, because if C was 14, A would be 11, which is smaller, yeah?
Yeah.
Yeah, so I think I disproved your claim that your method didn't work. Okay? So your method does work, it's just a matter of execution. And obviously I have a few more tools than you do right now, but so I think a lot of people, especially young, smart people, they kind of dismiss their ideas if they don't get to all the way, you know what I'm saying? It doesn't mean it's not good, you know? So actually what we have proved is that the substitution is worth 1 mark, okay?
Yeah.
So I mean, this is all very theoretical. Like the person who's marking it could just be like, I don't give a crap. I'm just giving 0 for everyone who doesn't get the answer. You know what I'm saying? Like they're like uni students marking this. So.
Oh yeah. So we have tournament of the minds once, and so our judges, they literally were making TikToks in the time when we were supposed to be preparing. Really sad, but it's okay. We still qualified for the state finals.
Hmm. Oh, okay, cool. Wait, Ethan, does this make sense? Aiden? Ethan.
Yeah, a bit.
Yeah, so I mean, so what happens with the problem? You see, like there's a moment where you might need to make a choice, right? And the rest is kind of you don't really have any choices, you know what I'm saying? Once you made that choice, the rest is kind of you're like following a set path now, you know what I
I
mean?
think it was work if we use B or C as well.
Oh, I think definitely it would work if that worked, then the others should work as well, right?
Yeah.
Um, but like the mathematician just fears the choice because once you made that choice, you're just kind of hoping it's good enough to get you to the end, right? You don't
Yeah.
really have any other. Oh, okay. What happened at the start of the problem? So let me just summarize.
Oh.
So let me just clear that. So what happened was essentially like this. So
I think we used that A was equal to 32 minus B minus C,
yeah. So we took the second equation, yeah, and we used it to get rid of one of the variables, yeah,
which was A.
which was a, yeah.
Yep.
So this was Cindy's approach, yeah, and I think this would be worth my mark, okay, like that first step, okay.
That's the mark. Sad.
Yeah, I mean, in theory, it's worth one mark. In practice, anything goes, right? The only time, like even normally, you don't even see the marking, so people can't even complain. Hi, I'll send her down in a second. Okay, see you. Okay, so we'll wrap this up. So basically, um, you're subbing in the second equation to the first equation. So then the first equation only has B's and C's in it. Okay, and then once you
We use the quadratic.
yeah, so once you expand everything out, you'll get like C squared something, and then a bunch of stuff with like C's, and then like 98 and some B's, right?
Yeah.
So then you treat that as a quadratic. Um,
Equation.
you treat that as a quadratic in C. So it's like C squared plus something C plus something that has no C's in it equals 0. Yeah?
Yep.
Okay. And to solve a quadratic equation um, is
That's a
is
formula.
essentially well-known school formula, yeah, quadratic formula. And the key to it is so whatever goes here.
It's called the B value.
So the answer would be C equals something plus or minus some square root, right? And the square root is always B squared minus
Something
4.
B.
Maybe this I could put this AC. Okay. So the solution to the quadratic is always C equals minus B plus or minus that on 2. Okay.
2A.
2A, yeah. Okay. And so the key here was that C has to be an integer, right?
Yep.
So so the 2A actually cancels in our case, so we only really have the B, and that's an integer. And so we need the square root thing to be an integer, okay? And the square root thing can only be an integer if the thing inside the square root is a square number, okay?
Yep.
And that really restricted the possibilities so that we only really got B was 2 values, right? And only one of them worked.
25.
Okay, and then we sub everything back in and we get the solution. Did you understand? Okay, good.